So, what happens when a person's name is lost, when all you have are the barest of clues? How do you give a face back to the nameless? We're about to go on a fascinating scientific journey, starting with the big clues left in our very bones and zooming all the way down to the unique code that's written in every single one of our cells.
Okay, here's our roadmap. First up, we're going to unpack what the puzzle of identity even means. Then we'll put on our forensic anthropologist hats and see what stories bones can tell. After that, we'll zoom right in on those tiny unique patterns on our fingertips, then jump into the high-tech world of biometrics, and finally, we'll crack the ultimate code to identity, our DNA.
All right, so first things first. We've got to set the stage. You see, establishing who someone is, especially in a legal setting, isn't just about recognizing a face. It's a really rigorous scientific process, where being certain is absolutely everything.
And that is the big question, isn't it? I mean, when you can't just ask someone for their ID, you need methods that are reliable, that are scientific, and that can be repeated. This constant need for positive, undeniable proof is what has driven this incredible evolution in forensic science. And you can really see that evolution right here. It's pretty amazing. We started out, literally measuring people's bodies with calipers. Then we discovered these invisible clues hidden in our blood. But the real game changer? 1984, DNA fingerprinting. That one discovery completely reshaped the justice system and led to these massive, interconnected databases that investigators use today.
So, let's dive into our first major technique. Let's see how the human skeleton, the very framework that holds us up, can give investigators a foundational biological profile to work with.
Forensic anthropology. It sounds complicated, but think of it as the science of making bones talk. These experts can take a skeleton that's been silent for years and get it to tell them a story about who a person was, how they lived, and maybe even how they died.
So, when investigators are faced with human remains, this is their starting lineup, the Big Four. And why these four? Well, think about it. If you can determine the sex, estimate the age at death, calculate the height, and get an idea of the person's ancestry, you've just dramatically narrowed down the pool of missing persons, from millions to maybe just a few thousand. It turns an impossible search into a real investigation.
And check this out. This shows you just how incredibly specific this work gets by taking very precise measurements of the skull. I mean, looking at the exact shape of the nasal cavity or the eye sockets, a forensic anthropologist can provide a really strong estimation of ancestry. It's another crucial piece of that identity puzzle.
Okay, so we've looked at the big picture with the skeleton. Now let's zoom way in, right to the surface of our skin, and talk about what is probably the most famous identification method of all time, the fingerprint. Just think about your own fingerprints for a second. They are totally, completely unique to you. They formed before you were born, and they will not change your entire life. And we can sort them into general categories. These three basic principles, this is the rock-solid foundation of fingerprint science. It's why they're such a powerful tool. So, the very first step when you look at a fingerprint is to classify its general pattern. Every single print on Earth can be sorted into one of these three buckets: an arch, a loop, or a whorl. This gives investigators a way to quickly start filtering through massive databases. But that general pattern? That's not enough for a positive ID, no way. The real magic, the thing that makes your print truly yours, is in the tiny details, what we call minutia. We're talking about specific little points, like where a ridge on your finger just stops. That's a ridge ending. Or where one ridge splits into two, a bifurcation. It's the unique map of all these little points that makes your fingerprint an undeniable signature. And today, of course, this whole process is super high-tech. A scanner, maybe like the one on your phone, grabs an image. Then software instantly analyzes it, finding and plotting all those unique minutia points. It basically turns your physical print into a digital code. Then an algorithm zips through a database looking for a match to that code.
All right, let's take a big step forward into the modern era, because really fingerprinting is just one type of a much bigger field called biometrics. And this field has come up with some truly remarkable ways to measure what makes us unique.
To put it really simply, biometrics is the science of turning your body into a password. It's all about using technology to measure and analyze the unique characteristics that make you, well, you. Now, this is a really important distinction to get. Biometrics basically falls into two big camps. First, you have physiological biometrics. This measures what you are, the physical, unchanging stuff like your fingerprints, your face, the shape of your hand. Then you have behavioral biometrics, which measures what you do, the unique patterns in how you walk, or sign your name, or even type on a keyboard. Both are useful, but the stuff you can't change is usually more reliable.
You've probably seen these in spy movies, right? Eye scanners. But they're actually two very different types. An iris scan reads the incredibly complex pattern in the colored part of your eye, and it can do it from a few feet away. A retina scan, on the other hand, maps the unique pattern of blood vessels at the very back of your eye, which means you have to get your eye right up to the scanner. And that difference in comfort is a big reason why iris scanning is way more common in things like airport security or unlocking your phone. All right, we've gone from bone to skin to the eye. Now we're going all the way down to the molecular level. Let's talk about what is, without a doubt, the most powerful and definitive method of identification that science has ever come up with: DNA profiling. So why is DNA the gold standard? Why is it the ultimate identifier? Well, it all comes down to its unbelievable uniqueness. Unless you have an identical twin, the specific sequence of your DNA is yours and yours alone. It's a genetic blueprint that you got from a random shuffle of your parents' DNA, and the odds of someone else having the same one are just astronomical. Now, here's a mind-blowing fact. You, me, and every other person on the planet, we are 99.9% genetically identical. Isn't that wild? But the key to everything is in that tiny leftover 0.1%. That little fraction is packed with repeating sequences of DNA that are super variable from person to person, and that's exactly what forensic scientists zoom in on. So how do they get from, say, a drop of blood to that definitive ID? Well, first, they extract the DNA. Then they use special molecules, like tiny scissors, to snip the DNA into smaller fragments. Next, they use electricity to sort all those fragments by size. And for the final step, they use special probes that only light up those unique, variable parts we just talked about. The result is a pattern of bands, like a barcode, that is one of a kind.
Okay, so we've looked at all these different puzzle pieces: bones, prints, biometrics, DNA, but how do they actually fit together in a real case? Let's bring it all together.
Here's the most important takeaway. A positive identification is almost never about one single piece of evidence. It's about building a case, layer by layer. Think of it like a funnel. Anthropology gives you a broad profile, taking you from millions of people down to thousands. A fingerprint or a biometric scan can point right to a specific person. And finally, a DNA match provides that ultimate scientific certainty, creating a link that is pretty much undeniable.
And that's what we'll end on. Our ability to measure and analyze what makes us unique is getting more and more precise every single day. I mean, we went from measuring bones to sequencing genes in just over a century. So what's next? What new biological signature will be the next fingerprint, the next strand in DNA? The hunt for who we are is a story that science is definitely not done writing. Thanks for tuning in.